Welcome everybody to the first 2023 Global R&D Meeting. And on that account, on the next slide, a happy Lunar New Year to everybody. Best wishes to everybody for 2023. Let's make this year the year of ICP. So now in the next hour, we're going to talk about what R&D is contributing to making this the year of ICP. And of course, we need all of you to join forces here to make that happen. So first, we're going to have some updates, in particular the R&D priorities for this year. Then Laura will give us an update on where we are with SNS, which will be one of the biggest priorities early this year. Then Maria will summarize some of the work that we've released in the last few weeks, in particular since our last global public R&D. Then, as part of the SNS, of course, everybody needs to think about tokenomics, and of course, your token should be valuable, but also you want to think about security. And Björn has some thoughts to share about how to prevent 51% attacks. And then we'll finish this meeting with the most favorite of everybody's, typically, which are the demos. Today we'll have custom domain names, ckBTC public dashboard. We'll see what that means. And then I really love the finishing demo from Hot or Not, contributed by our community. And before we go on to our updates, please don't shy away from asking all kinds of questions in the chat. We love your lovely, lively reactions and discussions on the chat. Thank you. So let's go on. Let's have a look at the priorities for our R&D teams for the next few weeks. On the next slide, we will see that the first priority the next couple of weeks is crowdfunding 3.0, also known as SNS or Service Nervous System. I mean, we're doing this to allow the community projects to raise funds this year, and also an end-to-end DAO is really a huge differentiator of ICP. No other blockchain can provide that. There's really two phases here. The first phase where like everybody in the R&D team is really helping each other to work that out, where we will address the learnings from launching SNS1 and make sure that we can launch the next SNS as soon as possible. So the focus here will be on user experience improvement, security, throughput, and all of that. And then in a second phase, after the next SNS, the next project has launched an SNS, we'll streamline the SNS developer experience. And I really do expect like SNS being one of the topics of the whole year, and hope to see many projects successfully launch an SNS. And the second priority, just really for the next few weeks of some of the team members, will be scalability and security roadmap. I think like scalability and security will be like one of the key themes of 2023 as well. And the first steps here is really figuring out what scalability bottlenecks we have, what we have to do to that end, what we want to do in terms of security and decentralization. I will say more on that just in a minute to give you an idea of what our thoughts there are. But obviously, I mean, we have a large team, and so of course we're also working on other things. And just go and see on the internetcomputer.org roadmap what we are having in petto for you. And also just give us feedback and reach out. So if your project wants to make use or critical use of some of those features, you're unsure what it entails, what the timeline is, and so on and so forth, please reach out. I mean, we can't prioritize things correctly if we don't know about some of this dependency or some of your needs. So I'd love to hear that. I'd love to talk about any of those. Okay, so let's talk a bit about scalability, where our thoughts are. So, because I want to see the internet computer scale like 100 or 1000x this year. So really, dApps should be able to scale in terms of users, in terms of canister, in terms of storage they use, that we make them available, in terms of throughput, latency. You know what, there's probably like an infinite list here. And what we hear from the community so far is, yeah, I guess some projects are reaching the limits of a single subnet, they're going multi-subnet. We've heard a lot about interest of more storage, some cheaper storage, better storage. And sometimes we're also hearing that people project resort to Web 2 services for some scalability issues. And of course, these really hurt me, so I don't want to see that. Let's do everything on chain. So if you think about using the Web 2 services, and of course, in some cases it's just not possible otherwise, but let's work towards like a fully on-chain infrastructure here. So reach out again here. So in the next few weeks, what we do towards that is really, but first of all, we have a few features released, and Maria will say more about that, like deterministic time slicing, more canister storage, and so on and so forth. So we're not just waiting until we have made our mind or heard from the community what other things we want to have. You've also heard, I guess, some tweets around massively increasing the storage that we want to have. So we were actively thinking around this, how we could do that. So that's like one thing that I want to get resolved in the next few weeks, and hopefully at the next public Global R&D present you some plans, what this would entail, how this would all look. And really, I guess like beginning of the year, you think about, okay, what should come up this year? So what we're doing now, just a few of us assess the current and upcoming bottlenecks, try to extrapolate what it would mean if we scale 100, 1000x, where we would see bottlenecks, and then define sort of the upcoming work. Again, here, if you are running in some bottlenecks that are not very obvious, also just reach out on Twitter, on email, on Slack, and let us know so we can do the correct prioritization here. Let's go to security, well, security also means decentralization. I guess decentralization you do on one hand for security, on the other hand, of course, also for joint ownership. So towards here, I mean, the goal is making the security for ICP even better, making sure we have more decentralization in many places. And here, so the concerns we hear from the community are number of nodes in subnet. What is a good number? I think that's actually a very interesting discussion. Also here we're going to do some works, maybe some forum discussions. And the other thing is decentralization of boundary nodes and voting. And here also we have some work planned. I mean, we've talked about that like the SNS governed boundary nodes. We have a roadmap there. We've got to update that roadmap with some concrete timelines in the next couple of weeks and publish that. We've spoken last year about the enhanced protection of the threshold ECDSA keys. One way is to have the different thresholds. Another way is of course, to use SEV-SMP. And as we speak, new nodes are being added to the internet computer that actually have the next generation hardware that features SEV-SMP. Once this is done, then we'll switch using those features so that actually these keys are even better protected. On a more high-level thing, what we're talking about now as well is security interaction between app and fiduciary subnets. So if you have subnets of different security levels, you want to have some support of that, because if you do all the work on like a, say, on a 13 subnet, you might overall then have your tokens on a fiduciary subnet, but maybe not get the whole security guarantee. You might just then have to build your app with a certain nodes security, and that, of course, that's not preferable. We really want to make sure that if there's tokens on a high security subnet, then also dealing with those tokens has the same kind of security. So we have some work planned that's there, and also I'm looking forward to talk more about that, but not today, but next time. Finally, also here we do the first the spring cleaning, if you want, assess the current state, define the work, see where we are, see where we want to be by the end of the year, and then present more of that. Also here, please reach out if you have some other concerns, something that I haven't mentioned here. What is your thoughts here, and let us know so we can define the priorities properly. Good. So far from the next couple of weeks, the prioritization and the work we're planning. And as you all know, we will have a huge focus on SNS, and to this end now I will hand over to Laura, who will give us an update where we are and when we can expect the next SNS project to launch. Laura, over to you.
Thanks, Jan. So before diving into the SNS roadmap, let us first briefly recap the stages that a project goes through when it launches an SNS. So in the first phase that we see here, the DApp is still controlled by the developer team. And in this phase, the developers should ensure that all their operations and tooling is sufficiently on-chain so that the DApp is ready to be managed by a DAO. On the next slide, we then see the next phase, which is the launch. So this is really launching the SNS, and of course, this in itself, it consists of multiple smaller steps. So the NNS approves the launch of the SNS canisters are installed, and then the decentralization sale happens, where participants can provide ICP in exchange for a share of the initial tokens. And after a successful launch, we reach the next stage on the next slide, which is a fully functional DAO. So now the DApp is controlled by the SNS DAO, which is in turn governed by the community. So I will present the roadmap by features that enable projects to go through each of those three phases successfully. And let's go to the next slide, please. Moreover, for each phase, I will present the project in terms of 3 milestones. So first, we identified what are really the blockers. As Jan said, we want to make sure that the first SNSs can launch as soon as possible. So the blockers are really about what things do we have to solve before this is possible. Then we want to tackle improvements. So in this category, we want to make the experience of the users and developers even better and improve what we have. And only then we want to add new features in the last category, which we call the add-ons. So let's go to the next slide, please, for looking what this means for this first preparation phase of an SNS. For the preparation, one of the most important features is that we want to provide guidelines for projects, how they can test that their daily operations still work, even if the DApp is under DAO control. And we want to provide some test SNS that this can really be tested in production. In terms of improvements, we want to make it easier for teams to reduce off-chain dependencies. And we will actually see one example of this in a later demo, where we have a feature that enables users to use their own custom domains on the internet computer, which means that they rely less on off-chain infrastructure. And finally, for add-ons, we would like to further evolve the developer tooling so that the SNS can be even better tested locally. So both the SNS launch, but also the integration of the SNS with the DApp. So then let's go to the next slide to look at what we plan for the launch. As a highest priority, we want to focus on making sure that the sale can handle more load. Also, we want to ensure that the sale participants have a better user experience. So this is the second point. In SNS1, there was a problem when people refreshed the front end that this could cause that a second participation for them in the sale was issued. And I will shortly explain on the next slide how we intend to avoid that going forward. Oh, sorry, we still need to stay on the same slide. That was just an announcement. Yes, thank you. In terms of improvements, we want to mitigate the effect of bots in the sale, and we want to provide better user documentation to explain how you can participate. And finally, as add-ons in the future, we would like to further improve the payment protocols with approve and transfer from the ICRC2 standard, and further automate the launch process, which currently still requires a lot of manual steps. Now let's go to the next slide, please, to see how we want to avoid these repeated participations due to refreshes. So what we want to do is a new payment protocol with a so-called ticketing system. So the idea is that the SNS sale, which you see here on the right, keeps tickets, which means that it tracks for all principals the status of whether they have an ongoing purchase or participation in the sale. If a principal logs into a front end, the front end or client would then, as a first step, check whether there's already a ticket for this principal, which means an ongoing payment. And if this is the case, it would then it would basically not allow the participation. If there's no ticket yet, it would create a new ticket, and only after these two steps issue a new participation. So the idea is that if at any point in time the principal refreshes the front end would again, as a first step, check whether there's already a ticket and basically learn the proper status of the ongoing payment. And only if this is finished, create a new participation. So this was just a very high-level overview, but I hope this gave you an idea. And let's now go to the next slide, please, to see the features that we want to do for the post-launch of an SNS. So first, as a blocker, of course, we need to fix all the bugs that we found in SNS1, as Jan already mentioned. And then as improvements, we want to further improve the UI, both in the SNS front-end tab to have a better user experience, but also in a new SNS dashboard, which helps both users and the developers to have more insight into what is happening in the SNS canisters. And further in the future, we then want to add voting in the SNS front-end tab and also provide better cycles management for both the SNS and the DApp canisters. So basically further automated to make this easier. And now I want to show you a little bit about this improvement part on the next slide. So here you can see a very quick preview of what the SNS dashboard and the front end looks like. So the main takeaway here is that they're both already live, so you can look at them. And here we aim to continuously add new features and improve them, but already have them ready to also collect feedback, and so that the users can already use them. Now we can go to the last slide. So this was already the overview of the SNS roadmap. Next slide, please. And you can find more information. We will post an even more detailed roadmap on a forum post, and we will also add it to the SNS website that is linked here. And we also have a new SNS frequent asked questions website, which is also linked here. So this is, just to let you know, this is still work in progress. So again, we want to continuously update it. But yeah, you can already find it under the link that we add here. This was it from the SNS side, and I hand it back. Thank you.
Thank you, Laura. Exciting plans. So for the rest of the meeting, let's go towards seeing what we have delivered lately. First in a rather compressed form, and then in a more extensive form by demos and so on. So yeah, Maria, over to you. Who will bring back the famous roadmap slide? Hit it, Maria.
Thanks a lot, Jan. Hi, everyone. We looked already into the future and looked into SNS, and I would really like to take the time and appreciate all the work that has been done in different areas, implementing and releasing recently new features. Many of them are community requested, so we are very excited to have them live and picked up by community. So let's see what's fresh from the all and go into the next slide. Yeah, and this is our famous roadmap that we share. So I would like to structure the highlights based on the area that features is shipped from. So we go one by one and see what's new in every area that we're working on. So next slide, please. Yeah, I'd like to start with the core protocol. And as Jan mentioned, we work towards scaling and also handling high loads. We did quite a few improvements there. So regarding scaling, we scaled canisters, allowing them to use 10x of the stable memory compared to just a year ago. So that's a huge improvement, and canisters can enjoy a huge stable memory improvement now. And the second that I would like to highlight is recently launched high replication subnet. So developers now have a choice to have their DApp on a subnet with a higher replication factor. The price for the subnet scales with the number of the nodes. One of the so-called fiduciary subnet that we've launched already and is live has already 28 nodes compared to the usual 30 nodes in an app subnet. Next slide, please. And regarding handling high load, there are quite a few improvements coming from crypto's state management and message routing. For crypto, we just launched caching delegations in the crypto library. That is a huge improvement in handling update calls. So for a large subnet, by caching those delegations when verifying the call messages, it led to roughly 11x improvement in a large subnet, for example, SNS subnet, and in general, it's 800x sped up. So that's huge improvement, the quickest and biggest recent win. For state management and certification, we are also in the process of rolling out a 4x improvement with the new tree hashing algorithm. That is also great improvement with subnets with many canisters. We also did some groundwork on async checkpointing, and regarding message routing, we also introduced request timeouts for better handling of high load and removed bottlenecks in canister-to-canister messages. So next slide, please. For the boundary nodes, we have two exciting features. One of them is custom domain names, highly requested by community, demo today, stay tuned. And a second one, WebSockets, also community requested. Demo is scheduled for the next public Global R&D. Our proof of concept is completed, and we're excited to share it with you next month. Next slide, please. Yeah, regarding system utils and dApps, besides shipping constant improvements in internet identity and SNS front-end app, I would like today to give a spotlight to ckBTC, a Ledger and Minter. We have it facing test Bitcoin network, and we'll hear more updates and demo today, and we'll be launching the real ckBTC very soon. For the ICRC standards, we shipped ICP Ledger, now basically supports ICRC1, and also a library, JavaScript library that interfaces Ledger and also ICRC supported ledgers, has been published in the NPM, and SNS front-end app is using it already. So, and in the working group, also established a proof transfer from ICRC2 token standard that is also being implemented now. Next slide, please. Regarding developer experience, there are a lot of Motoko-based library improvements. There we are post updates regularly. Please stay tuned and watch out for those updates from the team. But as a bonus announcement, I would like to highlight Motoko-san. This is bringing formal verification to smart contracts built in Motoko. This is pretty amazing because it allows high security guarantees for dApps and Web3 applications. So we built, the prototype was built for automatic verification for Motoko, and we're offering help to the community teams and grant proposal for the teams who would like to take it to the next level. Please watch out for a Medium post that is coming out today that has more details about this project and also grant announcement. And the next slide. Last but not least, it's exciting to see that there are new potential, 9 new potential node providers, and We see proposal submissions from different node providers to become a part of the network. Some of them has been voted by the community already on. So it's exciting to see the network growing and being more decentralized. So with that, over back to you, Jan.
Thank you, Maria. And thanks to everybody who was involved in all these amazing features. Thanks. So now let's switch back to SNS. So one of the things that you have to figure out when launching an SNS is tokenomics, like how many tokens you want to sell, how many you want to airdrop, how you make your tokens valuable, and so on and so forth. But if that is not even hard enough, the whole economics aspect, you also need to think about decentralization and security, in particular about the distribution of voting power throughout the lifetime of your project, so that no single party can actually take control, maybe abuse that control. So let me hand over to Björn, who has been thinking hard about that and has some insights to share for everybody. Over to you, Björn. Thanks.
Thank you, Jan. Yeah, so I want to talk about how to mitigate 51% attacks on SNS. So yeah, I think such an attack essentially means like an attacker acquires the majority of the voting power of the DAO and then controls it. You know, that can be, of course, beneficial for many reasons. I mean, for example, the attacker can drain the funds in the treasury of the DAO or can misuse the DApp in other ways. I think it's a relevant topic for you if you are a developer who plans to launch an SNS. It's also relevant for you if you are interested in participating in upcoming SNS sales, or also if you're an SNS voter who is asked about approving or rejecting upcoming sale proposals. And in this presentation, I will show how such an attack can be mitigated, at least to a certain extent, by choosing an appropriate SNS tokenomics configuration. Next slide, please. Yeah, so let's start with illustrating how such an attack could play out. So what you see here on this pie chart is the voting power distribution at Genesis as per the planned configuration for open chat. So you see that you have, I mean, 3 main groups involved: seed funders, developer team, and sale participants. And sale participants have the majority of the voting power. And now if you assume, you know, that this sale was distributed to many independent individuals, then the SNS would be indeed decentralized. Now let's simulate an attack on that setup on the next slide. And the first step would be an attacker tries to acquire a significant amount of tokens or neurons in the sale. So here I made actually the quite extreme assumption that the attacker would be able to acquire 75% of the sale. And now if you look at the pie chart, you see that at Genesis, such an sort of attack would then result into a voting power of 42% for the attacker. So not yet the majority. So the question is, are we safe? And the answer is no, as you can see on the next slide, because what the attacker could do directly after Genesis could sort of stake all tokens that the attacker acquired, because some of them are liquid, some are already staked, and also increase the lockup time for all of its token sitting in neurons to the maximum. For open chat, that would be 1 year. And now you see with that additional adjustment in the neuron configuration, now the attacker would have 53% of the voting power and hence the control. And now we can do like malicious things, like, for example, draining the treasury of the DAO. And as you can see on the next slide, the situation gets actually even worse if you assume that not all sale participants would vote on everything. I mean, for example, if you assume that only 50% of sale participants vote, which I mean clearly can happen because not everybody always votes on everything, then the attacker would actually even have more sort of active voting power. And in this case here, 56%. So now the question is, okay, so how can we mitigate that? And as you can see on the next slide, So one key idea is like that you can use the community fund to mitigate such an attack. Maybe as a quick recap, the community fund is a vehicle for the community, for the NNS community, to invest in the IC ecosystem, and it works by sort of flagging your NNS neuron as community fund, and then if you do that, you expose the maturity that you have earned with your neuron so far to the community fund. And now what you can do as a developer is you can sort of, as part of the sale parameters, you can specify a suggested community fund participation. For example, Open Chat plans a participation of the community fund of 333,000 ICP, which is a third of the maximum funding target of 1 million ICP for Open Chat. Like such a setup would result in a sort of voting power distribution as seen in this pie chart on the right hand side. Now you see essentially like that the sale is now split in two groups. One is sort of the community fund contribution, and the second one is sort of the direct investors. I think one key assumption here, right, for which we're making is that the attacker is not able to build up a significant stake or maturity in the community fund. And that assumption is made for two reasons. First of all, in order to have a lot of maturity in the community fund, you have to stake and lock up ICP for a long time. So you have a long-term commitment to the IC to make. And second, maturity is not something that you can sort of buy directly, but you have to build it up over time. So in particular, the attacker cannot get via short-term investment a lot of maturity. That's something which really requires a long-term commitment. Now, if you go to the next slide, you see under that setup now, if we replay the attack, so the attacker buying 75% of this available sale tokens, increasing the lockup period, and even if we make the assumption that sale participants would only vote 50% of the time, you see that the attacker would only have 43% of the voting power. So, and that illustrates that even under that quite extreme attack, like the community fund is quite a powerful mitigation. As a quick outlook, I want to mention that, of course, there are other ways how you could improve the resilience against such attacks. I mean, one idea we're thinking is to increase voting thresholds for proposals which affect the distribution of treasury funds. You could also alternatively think about sort of maybe delaying like the exercisement of like a distribution of such proposals. So these are things that we could do in a second phase. So there's definitely more possible. Now on my next slide, and that's the final one, I wanted to let you know that there is training material and tools available where you can make yourself familiar with SNS tokenomics parameters. So you see like the QR code on the right hand side that brings you to a wiki page where you have a training deck, but also a tool where you can sort of get hands-on and play around yeah, do various assessments. I mean, you can do like the kind of assessments you saw in this presentation. You can simulate and parameterize an attack, but you can also investigate token price ranges, the development of total supply over time, and just simply get familiar with all the different configuration abilities that you have. In addition, we are sort of offering some sort of live sessions where you can interactively discuss this material. So we have some training sessions that are starting this week where we talk to interested SNS projects. Also, there's the idea to have a tokenomics Twitter space and also workshop in collaboration with Voxler Finance in February and March. And so if you're interested in joining, please reach out using the email address on the bottom of this page. All right.
Thank you, Björn.
Thank you very much. Back to you, Jan.
Thanks, Björn. So now let's go to my most favorite part, the demos. The first one is has been long awaited. It's about custom domain names for canisters that are now available to any ICP canisters. So Or, tell us more.
So hello, my name is Or, and I'm an engineer on the boundary nodes team at DFINITY. Today we're excited to present to you a much requested feature that is custom domains on the internet computer. So let's dive right in and see why this feature is being introduced. So when a canister is deployed to the IC, a canister ID is created, which can then be used for visiting the canister. This is quite convenient and is broadly used, but in many cases, developers would like to serve their canisters over a more customized domain that fits their brand. There are several different solutions for this, which have allowed high-profile projects to use their own domains. This usually requires private infrastructure and a custom version of the service worker. And we wanted to lower the barrier of entry and make it easier for developers to use custom domains without needing to spin up private infrastructure or worry about certificate management. So let's see how this new feature works. At a high level, when a user visits a canister domain, it gets resolved to the IP of a boundary node, which then forwards the request to the canister on the IC. The same thing should happen with a custom domain. To do this, the developer needs to do a few things. First, they have to configure their domain's DNS to point to the IC and to their canister. Second, the canister has to expose a file under a custom domains path so that it can be verified that they approve the canister to be served over this domain. In order for the boundary node to know about this custom domain, the developer initiates a request with a boundary node. Once this happens, the boundary node runs a series of checks to make sure that the developer has set up DNS properly. If the checks pass, we queue the domain for immediate processing in the custom domains canister. This canister is used to coordinate the work of processing these domains between all the boundary nodes. The request is then picked up by a boundary node, which initiates an order with Let's Encrypt for a new SSL certificate. Once the certificate is generated, it is distributed to the rest of the boundary nodes. After this process is complete, the domain is available to use. So let's see a demonstration of this in practice. First, we'll visit a canister by going to its usual canister ID domain. As you can see, the canister is available just as you'd expect. That said, we'd like to expose this canister over a custom domain. And as we saw before, this requires that the canister expose a well-known custom domains file so that we can verify ownership of the canister. So let's make sure this is set up correctly. Here we see that the canister indicates several domains from which it can be served. Next, I'll show you a quick screenshot proving that earlier today, I set up the required DNS records. These indicate that the canister would like to serve, as well as provide a delegation CNAME so that we can issue a certificate on behalf of the developer. So now we're ready to submit the domain to the boundary node. Once we do that, we should get back a registration ID so that we can use it to track our domain status. Looking at the status of our domain, we can see that it is currently being processed, as you can see here. This takes 2 to 3 minutes. So in the meantime, we'll switch to looking at a domain that was already set up earlier today. As you can see, the status of this domain is available, which means that the certificate was generated for it and distributed to the boundary nodes. It's worth noting the certificate will be renewed automatically every 60 days. We can now visit the custom domain in the browser and see that it's serving our canister. A few next steps are to finish the internal testing and release this to the general public. Additionally, we're planning to build a wizard app that will walk a user through the process of setting up their domains. Lastly, I'd like to thank the Boundary Node, Trust, and Security teams for their help in delivering this feature. That's it for our demo. Thanks for watching.
Thanks so much, Or. So Cenki Bitcoin is the next demo. It's the latest from the Bitcoin integration stream of projects. And just like the demo before, it shows something that cannot be built anywhere else and really demonstrates the superpowers of the internet computer. Manu, the floor is yours.
Thank you, Jan. Hey, everybody. I'm Manu. Together with Mario, I'll indeed give an update on the chain key Bitcoin efforts. So to recap, chain key Bitcoin, or ckBTC, is a token that we're working on at DFINITY that will be native to the internet computer. It will live on the internet computer, which means it can be transacted very quickly and efficiently. And the idea is that one ckBTC represents one Bitcoin. Now you might ask, why do we need this? Because canisters can already hold real Bitcoin with the Bitcoin integration that we launched last year. But as you might know, Bitcoin transactions are quite slow and expensive, which means that there's many things you cannot do with it, right? You cannot tip small amounts of Bitcoin very quickly, for example, because all your money would be lost in fees. And the idea is that you can do this with ckBTC because it lives on the internet computer. How will this work? Well, we'll have a canister smart contract that builds on this Bitcoin integration that we launched end of last year, and that canister can now exchange real Bitcoin for ckBTC and vice versa. So without some centralized entity in between. Next slide, please. And today we're going to talk about, I guess, the transparency and the trustworthiness of this. So as a user, as I said earlier, you can send real Bitcoin to these canisters. You can give it to the control of the canister, and you would receive ckBTC in return, which is now yours. Now you can very quickly and efficiently transact in that. And you can trust that this token has value, because later you might say, I want to go back to these canisters. Here's your ckBTC back, and I want to receive the underlying Bitcoins back. And this means it will always have the same value as Bitcoin. Next slide, please. But now a critical user might wonder, like, why can I actually trust this, right? Is my ckBTC really worth as much as a Bitcoin? Can I trust that I can redeem my ckBTC for real Bitcoin? How do I know that even exists, right? How do I know that the canister actually has all the underlying assets? And of course, in the industry, we've seen a lot of funds disappearing and exchanges going bankrupt. So, the user would be right to be worried about these things. Next slide, please. So our answer to this is twofold. The technical answer is that the ckBTC canisters are under SNS control, which means that any change to these canisters must go through an NNS proposal where anybody can verify the source code and make sure that you can inspect the source and you can see that the canister does not steal your Bitcoin. But this is, of course, quite a technical answer, and it's pretty challenging to do. So what we're going to demo today is an easier way to convince yourself that ckBTC is indeed worth as much as Bitcoin, because it's backed one-to-one. So what we build is that these ckBTC canisters expose a dashboard which very transparently shows all the Bitcoin that it holds, such that users can easily verify this one-to-one backing between ckBTC and Bitcoin. And for that, I'll hand it over to Mario, who is going to show this in action.
Yeah, thanks, Manu. Hi, everyone. I'm Mario from Financial Integrations, and I'm going to show you this neat feature of the ckBTC Minter, the dashboard. So the ckBTC Minter exposes the dashboard at the endpoint dashboard. Everybody can access it. This dashboard contains the full state of the Minter, some metadata, the full metadata, so the configuration of the Minter, and finally the logs of the Minter. So let's start from the top. The metadata. So we have the Bitcoin network, testnet, the main address of the Minter on the Bitcoin network. Then some configuration, including the ledger ID that you can see here. And then finally, the total Bitcoin that are managed by the ckBTC Minter. So I'm going to show you how this number is calculated later, but we can already use this number to verify that one ckBTC is in fact backed by 1 Bitcoin. So as you can see, the total Bitcoin managed is 1.188. I can go on the ledger and check that the total supply of the ledger is smaller than this number. So if I now go to the canister UI of the ledger, so it's this one, MC6RU, yes. I go down, there is a meter called total supply, which I'm going to call now, and this gives me 1.183 roughly, which is indeed smaller than 1.188. All right, so let's go to the state of the ckBTC Minter. So the first table are the pending transaction requests. So every time you ask to redeem your Bitcoin, the ckBTC Minter will add an entry to this table. Your request will stay in this table for several minutes until the Minter is ready to serve your request. As soon as the Minter is ready to serve your request, the request will be moved to the next table, the in-flight retrieve Bitcoin requests. And this table contains your request while it is part of a transaction that is being created, signed, and sent to the Bitcoin network. The next table are the submitted transactions. This is a bit more interesting. Those are the outgoing transaction to the Bitcoin network. So this table contains all the information about each transaction, including the request that have been served with the transaction. We serve multiple requests per transaction to minimize the fee. The next table are the finalized requests. So this one for each request contains the amount and the scanner status. If the request has been confirmed, then you also have the transaction ID that served that particular transaction. So one nice feature of this dashboard is that the transaction IDs are hyperlinked, and if you click on that, you have a link to the block stream, so to the block explorer of the Bitcoin network, and you can verify there that the transaction is indeed correct. All right, let's go to the most important tables of the Minter. So there are two very important tables that, let's say, when you sum them together, give you the total Bitcoin managed by the Minter. The first one are the available UTXO, and the second one are the unconfirmed change UTXOs. The available UTXOs are the UTXOs that the user will send to the Minter when they want to get ckBTC. And they are listed here, so including their value. You can verify each one of these lines by going to the block explorer. So as an exercise, we can verify the first one. So this is 6,000 Satoshi, and it's the first fee out of this transaction. So I'm going to click here, go to the block explorer, go down, and on the right, you have the first fee out, which is indeed 6,000. So you can verify each one of those. At the end of the table, you have, there are a lot of entries. You have the total Bitcoins owned by the Minter, so 1.188. So the second table is unconfirmed change UTXOs. Those are the UTXOs that the Minter sends to itself. So when you request Bitcoins, the Minter charges a fee, and this fee takes the form of a UTXO that goes back to the Minter. So this means that it's part of a transaction, and until the transaction has been confirm, the UTXO will be visible in this table here. So the reason for that is that those UTXOs are still available to the minter, just not right now. They will be available in future. So if you sum the total of unconfirmed change UTXO with the available UTXO, you get the total Bitcoin managed by the ckBTC minter. Okay, the next table is mainly for debug. It links accounts and address with the transaction IDs. So this is useful for us to see which accounts have which UTXOs. Then if I go down, you have three more things. The first one, the update balance principal spending and retrieve Bitcoin principal spending are the current concurrent principals calling the two methods. This is nice to see the load on the ckBTC minter, although we expose the same through the matrix, and it's probably better to see through the matrix because you can plot it. And finally, we have the logs. So with the ckBTC minter, we have decided to keep the logs in memory so that we can expose them as nice canister data, for instance, as part of a dashboard. And those you can verify what the minter is doing by checking the events in this table. So for instance, the last line here, it's the minter, means that the ckBTC minter has been upgraded and it replayed 282 events. And that's it for the dashboard. Thanks, Manu. Back to you.
Cool, very nice. Then I can maybe touch a little bit on the timeline of all of this. So everything you see here is done with this CK test BTC. So I guess the test version of ckBTC that works with Bitcoin testnet. This is all live today. You can play around with this. There's a link here to the forum that tells you how to get started with that. And we're putting the finishing touches on the real deal, which we're hoping to launch in the coming weeks. Yeah, so you'll definitely hear more about that very soon. Thanks for your attention, and please ask your questions in the chat. Back to you, Jan.
Thank you, Mario and Manu. And we're already coming to the last demo of today. And this is a nice closing of the loop, because we sort of started out with saying, okay, this year should be the year of scaling on the ICP. And the next demo is hot or not. And I guess there will be one of those guys that will scale like crazy this year. Rishi, over to you.
Well, thank you so much, Jan, for that wonderful introduction to us. Well, hello, everyone. I am Utkarsh, and I'm one of the co-founders of Hot or Not. So Hot or Not is essentially a decentralized TikTok-like social media app, which integrates prediction markets on the social content. Now, what this allows us to do is to provide monetization avenues for practically every single social media user out there in the world. Now, in the traditional ecosystem or the social media ecosystem that we have, more than 98% of the users, or around 4.6 billion users, are not rewarded with any kind of financial incentives for spending the time that they're spending on these platforms. Now, what this does is results in wasting of more than 11.5 billion man-hours of productive time every day, which is down the drain scrolling on social media platforms. Now, in addition to this, in the existing ecosystem, very few players, control or yield an unprecedented amount of control over the existing, over the entire ecosystem. And hence, they're able to sway the platforms based, to suit their agendas. And thus, there is a need for something which makes it more decentralized. Now, that is where Hot or Not sits at the intersection of social media, betting, and decentralization, to create something which provides monetization avenues for all types of social media users, whether they are creators or they're lurkers. And the decentralization also helps in giving the control back to the community while making it more equitable between the various stakeholders in the ecosystem. Now, let's just look at the various pillars on which Hot or Not is based on. So the short video social media platform is essentially a TikTok-like platform which forms the basis of Hot or Not, the entire Hot or Not platform. Over here, you can simply upload your videos, share it with your friends and family, and increase your reach or your social clout, as more and more people see your video. Now, this is primarily targeted towards the monetization for the creators. The second and the more important layer is perhaps the hot or not betting ecosystem, which is primarily for the monetization of the lurkers or the passive observers on the ecosystem. Now, how this works is very simple. Whenever a video is uploaded on the platform, it goes into the hot or not feed. The users can now bet whether the video will be hot or not and stake some tokens to substantiate the bet. The results are declared every hour. And the user who voted with the majority are rewarded with 2x tokens. The user who voted on the other side, well, unfortunately, it is a bet, so you lose that money. So in this manner, the lurkers are able to monetize the time that they're spending on the platform without having to go through the traditional route of creating content on social media. Now, we launched our current app on 1st of October, and in the last 3 months, we have seen a tremendous growth of users on the platform with more than 42,000 users joining the platform in the said period. The users are coming from practically all across the globe, and they're spending some significant time on the platform. The most interesting part, all of this without spending even a single dollar on marketing or user acquisition. So this is all organic growth that we are seeing from the community. Now, before we move forward, let's just look at how the product works. So now when you log on to hotornot.wtf, this is where you land. Well, not actually this, but whatever is the latest video that is there on the feed. So this is essentially the home feed, which basically contains all the videos that have been uploaded by the various users on the platform. The videos on this feed are ranked based on an algorithm, which uses several parameters like the number of likes, number of shares, or the age of video to rank these videos in a particular order or a predetermined order. Now, while scrolling through these videos, the user can either mute or unmute the audio to listen to these videos as per their own convenience. Now, the platform has been designed in a manner that for viewing the content, a user does not have to log in. This allows us to prevent or lower down the barriers to entry for the incoming users. A user will be required to log in only when they have to interact with the platform. So, for example, if a user wants to like a comment or share like a post or share the post. For logging in, the user can simply go to the menu tab and log in using either the internet identity or the Google NFID, whatever suits them the best. Now, once the user is logged in, they can go to their profile and look at whatever content they put up and how many people are following them and so on and so forth. Or they can come back to the home feed and start scrolling through the other videos. Now, on top of this, we see this small bar over here where using which the user can migrate to the hot or not feed. Now, you see this right now is coming soon because this is under development and should be out by the end of this month. Now, over here, the user can again vote on a video as hot or not, stake tokens, and indulge in the speculation on the prediction markets on the platform. Now, the user can also upload their videos. So they can use this plus button to upload either a live video that they're capturing using their camera or an existing video from their gallery that they have already captured. They can also view the profile of other users, looking at how many people follow them, or they can follow them themselves, looking at whatever content they've put up, the particular profile has put up, how many, what kind of tokens they've earned, and several other information. For accessing the wallet, the user can simply go to the wallet where they can see their wallet balance and also the various transactions that have happened in the past for this particular wallet. Now, coming back to the technical architecture of the platform, the platform is entirely built on Internet Computer Protocol, and we're using a multi-canister architecture to build the platform. In this case, every user is awarded with their own canister, which stores all the pertinent information related to that particular user. We're using a progressive web app, which is the hotornot.wtf, to deliver this experience right now to the users. But the native apps for iOS and Android are already under development and on the horizon for improving our user experience. Now, having implemented the basic social media application, the next steps primarily include the deploying of the hot or not speculation and the development of the native apps, in addition to or followed by several other modules such as the decentralized content moderation or peer-to-peer betting, and among others. The project is primarily backed by a team of serial entrepreneurs who come from diverse backgrounds, bringing in more than 35 years of combined experience in various fields of business. And we are also backed by several VCs or investors and institutions from across the globe. Well, thank you so much for your attention, and do remember to join us on hotornot.wtf. Over to you, Jan. Thank you.
Thanks, guys. Really looking forward how this develops in the next few weeks and months, and see what the status is by the end of the year. So unfortunately, we're already at the end of all these exciting demos, but fortunately, we have another one scheduled in about a month from now, namely on February 22nd. And yeah, thanks for attending. Again, all the best wishes for this year, and let's make this year the year of ICP. Thanks, everybody. Bye-bye.